Hello students, welcome to this lecture 1 Arithmetic Progression. So in this lecture we will discuss exercise 5.3. Okay. So here in this question, here we have asked how many terms of the AP 9, 17, 25 must be taken to give a sum of 636. Okay. So here you have to find number of terms for which this AP must be taken to give a sum of 636. Okay. So here we let there be n terms of this AP. And for this AP, first term A is 9. And the common difference D, this is equal to A2 minus A1. And this is equal to 17 minus 9. And this is equal to 8. Okay. And we know that the sum of first n terms of an AP, that is Sn, is equal to n by 2 times 2a plus n minus 1 times t. Okay, so now if we apply this formula and if we put these values of a, d in this formula, then we get x636, this is equal to n by 2 times 2 times a plus n minus 1 times 8, and this implies 636, this is equal to n by 2 times 18 plus n minus 1 times 8. Okay, and it implies 636, this is equal to n times 9 plus 4n minus 4, and it implies 636, this is equal to n times 4n plus 5, and it implies 4n square plus 5n minus 636 is equal to 0. Okay, and it implies, now here we will use splitting the middle terms. Okay, splitting the middle terms, and here we'll factorize this quadratic polynomial as 4n square plus 53n minus 48n minus 636 is equal to 0. Okay, so here from these two terms we can common out n, then we get n times 4n plus 53, and from these two terms we can common out minus 12. Minus 12 times 4n plus 53, this is equal to 0, and it implies 4n plus 53 into n minus 12, this is equal to 0. Okay, so now either 4n plus 53, this is 0, or n minus 12, this is equal to 0. Okay, and it implies n is equal to minus 53 by 4, or n is equal to 12. Okay, so we know n cannot be negative number. Okay, so n cannot be minus 53 by 4, as the number of terms can either be negative nor fractional. Therefore, neither be negative nor fractional. Therefore, n can only 12. So here we can take the value of n is equal to 12 only. Okay. So now let us move to next question. So in next question, it said to us the first term of an AP is 5 and the last term is 45 and sum is 400. Then we have to find the number of terms and the common difference. Okay. So here first term is 5, last term L is 45 and sum is 400. So let us solve this problem. So given that A is 5, L is 45, and the sum Sn is equal to 400. Okay, and we know that this formula Sn, this is equal to n by 2 times A plus L. Okay, and now if we put these values of A, L and N, then we get 400. This is equal to n by 2 times 5 plus 45. Okay, and it implies 400, this is equal to n by 2 times 50, and it implies n is equal to 16. And now we know the last term, that is nth term L, this is equal to A plus n minus 1 times D. Okay, and it implies 45, this is equal to 5 plus 16 minus 1 times d, and it implies 40, this is equal to 15 d. Okay, and it implies d is equal to 40 by 15, that is equal to 8 by 3. Okay, so the common difference is 8 by 3, and in this question here we have the first term and the last terms of an AP, that are 17 and 350 respectively. Okay, and if the common difference is 9, then how many terms are there and what is their sum? Okay, so here for this question we have to first find how many terms are there, okay, and what is their sum. So here given that first term A is equal to 17, last term L is equal to 350, and the common difference D is equal to 9. And let there be n terms in the AP. Okay, so here we let there be n terms of this AP. So we know this formula, last term L is equal to A plus n minus 1 times D. Okay, and it implies 350. This is equal to 17 plus n minus 1 times 9. Since the first term is 17 and the last term L is 350, and the common difference D is equal to 9. Okay, and it implies 333. This is equal to n minus 1 times 9, and it implies n minus 1, this is equal to 37, and it implies n is equal to 38. Okay, so we know that sum of first n terms of an AP is n. This is equal to n by 2 times A plus L. Okay, and here we have the value of A is equal to, so we know this formula Sn, this is equal to n by 2 times A plus L, and here we have the values of n, A and L. Okay, now if we put these values A, L and N in this formula, then we get Sn, this is equal to 38 by 2 times 17 plus 350. Okay, and this is equal to 19 times 367, and this is equal to 6973. Thus, this AP contains 38 terms, and the sum of terms of this AP is 6973. Okay, so the answer is this AP contains 38 terms, and sum of these terms of this AP is equal to 6973. And then next question, it's said to us find the sum of first 22 terms of an AP in which the common difference D is equal to 7, and the 22 term is 149. Okay, so here we have to find the sum of the first 22 terms of this AP. Okay, so let us solve this problem. So we have common difference D is equal to 7, and A22, this is equal to 149. Okay, and now we need to find sum of first 22 terms of this AP. Okay, so we need to find S22, and here we know the nth term An, this is equal to A plus n minus 1 times common difference D. Okay, and here A22, this is equal to A plus 22 minus 1 times D, and it implies 149, this is equal to A plus 21 times 7. Okay, and if we calculate it, then we'll get the value of A. So here the value of A is equal to 2, and we know that the sum of first n terms Sn, this is equal to n by 2 times A plus An. Okay, and here we know the value of n, value of A, and the value of An. Now if we put these values in this formula, then we'll get Sn is equal to 22 by 2 times 2 plus 40, 149. Okay, and this is equal to 11 times 151, that is equal to 1661. Okay, now in this question here we have to find sum of first 51 terms of an AP whose second and third terms are 14 and 18 respectively. Okay, so we have to find the sum of first 51 terms of this AP. Okay. So given that second term A2, this is equal to 14, and we have given the third term A3 is equal to 18. And we know this formula, the nth term of an AP, an is equal to a plus n minus 1 times d. Okay, so here the common difference d is equal to a3 minus a2, that is equal to 18 minus 14, that is equal to 4. Okay, and we know the second term a2, this is equal to a plus d, and here we have a2 is equal to 40 and the value of d is equal to 4. So now we can find the value of a. So 14, this is equal to a plus d, that implies a is equal to 10. Okay, so the value of a is equal to 10. And we know that sum of first n terms Sn, this is equal to n by 2 times 2a plus n minus 1 times d. Okay, and S51, sum of first 51 terms, this is equal to 51 by 2 times 2 times 10 plus 51 minus 1 times 4. Okay, and this is equal to 51 by 2 times 20 plus 50 times 4. That is equal to 51 times 220 by 2, that is equal to 51 times 110, that is equal to 5610. Okay, so sum of first 51 terms, this is equal to 5610. And now in next question, here it said to us, if the sum of first 7 terms of an AP is 49 and that of 17 terms is 289. Okay, then we have to find the sum of first n terms. Okay, so given that S7, this is equal to 49 and S17, this is equal to 289. Okay, and we know this formula, Sn, this is equal to n by 2 times 2a plus n minus 1 times common difference d. Okay, so S7, this is equal to 7 by 2 times 2a plus 7 minus 1 times d, and here S7 is 49 and the value of so S7 is 49. So 49, this is equal to 7 by 2 times 2a plus 6d. Okay, and it implies 7 is equal to a plus 3d, and it implies a plus 3d is equal to 7, and naming this equation number 1. And similarly, we have the sum of first 17 terms of an AP is equal to 17. Okay, so similarly 289, sorry. So similarly S17, this is equal to 17 by 2 times 2a plus 17 minus 1 times d, and it implies 289, this is equal to 17 by 2 times 2a plus 16d, and it implies 17 is equal to a plus 8d, and it implies a plus 8d is equal to 17. Okay, now naming this equation number 2, and if we subtracting this equation, okay, if we 1 from equation 2, then we get this 5d is equal to 10, that is d is equal to 2. Okay, and from equation 1, if we put the value of d is equal to 2, then we get a plus 3 times 2, that is equal to 7, and it implies a is equal to 7 minus 6, that is equal to 1. Okay, so the first term of this AP is equal to 1. And now sum of first n terms. Okay, Sn is equal to n by 2 times 2a plus n minus 1 times d. Okay, so this is equal to n by 2 times 2 into 1 plus n minus 1 times 2, and this is equal to n by 2 times 2 plus 2n minus 2, and this is equal to n times 2n by 2, and this is equal to n square. Okay, so the sum of first n terms of this AP is equal to n square. Now in question number 10, here you have to show that a1, a2, a3 dot 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 en comma dot 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 form an AP where an is defined as below. N is equal to 3 plus 4n, and second is n is equal to 9 minus 5n. Okay, so also find the sum of the first 15 terms in each case. Okay, so Here for first one, we have given the nth term of this AP, En is equal to 3 plus 4n. Okay. And now we can find the first term, that is A1. So A1 is equal to 3 plus 4 times 1, that is equal to 7. Okay. And A2, this is equal to 3 plus 4 times 2, that is equal to 3 plus 8, and this is equal to 11. And A3, this is equal to 3 plus 4 times 3, and this is equal to 3 plus 12, and this is equal to 15. Okay. And A4, this is equal to 3 plus 4 times 4, that is equal to 3 plus 16, that is equal to 19. Okay. So A1 is equal to 7, A2 is equal to 11, A3 is equal to 15, and A4 is equal to 19. Okay. So it can be observed that A2 minus A1, this is equal to 11 minus 7, that is equal to 4. Okay. And A3 minus A2, this is equal to 15 minus 11, that is equal to 4. Okay. And A4 minus A3, this is equal to 19 minus 15, that is equal to 4. That is AK plus 1 minus AK is same every time. So therefore, this is an AP with common difference as 4, and the first term is 7. Okay. So AK plus 1 minus AK is the same every time. So this list of number, the given list of number is an AP with common difference as 4 and first term as 7. Now sum of first n terms. So Sn, this is equal to n by 2 times 2a plus n minus 1 times t. Okay. So now sum of first 15 terms, that is S15 is equal to 15 by 2 times 2 into 7 plus 15 minus 1 times 4. And this is equal to 15 by 2 times 14 plus 56. And this is equal to 15 by 2 into 7t. And this is equal to 15 into 35. That is equal to 525. Okay, so the sum of first n terms Sn is equal to 525. Now it can be observed that A2 minus A1, A2 minus A1, this is equal to minus 1 minus 4, this is equal to minus 5. A3 minus A2, this is equal to minus 6 minus of minus 1, that is equal to minus 5. A4 minus A3 is equal to minus 11 minus of minus 6, this is equal to minus 5. That is AK plus 1 minus AK is same every time. Okay, so therefore this is an AP with common difference as minus 5 and first term as 4. Okay, and the sum of first n terms Sn, this is equal to n by 2 times 2a plus n minus 1 times d. Okay, and now S15, this is equal to 15 by 2 times 2 into 4 plus 15 minus 1 times minus 5, and this is equal to 15 by 2, this is times 8 plus 14 times minus 5, this is equal to 15 by 2 into 8 minus 70, this is equal to 15 by 2 into minus 62, this is equal to 15 into minus 31, this is equal to minus 465. Okay, now let us move to next question. So in next question, it said to us if the sum of first n terms of an AP is 4n minus n square. And then what is the first term, that is S1? What is the sum of first two terms? And what is the second term? And similarly find the third and 10th and nth terms. Okay. So we have given that Sn, this is equal to 4n minus n square. So first term A is equal to S1. This is equal to 4 times 1 minus 1 square. That is equal to 4 minus 1, and this is equal to 3. Sum of first two terms S2, this is equal to 4 times 2 minus 2 square. That is equal to 8 minus 4, and this is equal to 4. Okay. So second term A2, this is equal to S2 minus S1, and this is equal to 4 minus 3, this is equal to 1. Okay. So the common difference D, this is equal to second term minus first term, means A2 minus A1, A2 minus A, this is equal to 1 minus 3, and this is equal to minus 2. And the nth term An, this is equal to A plus n minus 1 times T, and this is equal to 3 plus n minus 1 times minus 2, and this is equal to 3 minus 12 plus 2, and this is equal to 5 minus 2n. Okay, so the innate term of this AP is equal to 5 minus 2n. Now, therefore, A3 is equal to 5 minus 2 times 3, and this is equal to 5 minus 6, and this is equal to minus 1. And the 10th term, A10, this is equal to 5 minus 2 times 10, that is equal to 5 minus 20, and this is equal to minus 15. Okay, hence the sum of first two terms is 4, and the second term is minus second term, third term, 10th term, and nth terms are minus 1, minus 15, and 5 minus 12 respectively. Okay, so now let us see question number 12. So here you have to find the sum of first 40 positive integer divisible by 6. Okay, so let us solve this problem. So the positive integers that are divisible by 6 are 6, 12, 18, 24, dot dot dot. Okay, so it can be observed that these are making an arithmetic progression whose first term is 6 and the common difference is 6. Okay, so here A is equal to 6, D is equal to 6. Now we have to find sum of 40 terms, first 40 terms of the positive integer that are divisible by 6. Okay, so now as we know this formula is n, this is equal to n by 2 times 2a plus n minus 1 times common difference d. Okay, so if we now put the value of n is equal to 40, the value of a is equal to 6, and the common difference d is equal to 6. Okay, then we get s40, this is equal to 40 by 2 times 2 into 6 minus plus 40 minus 1 times 6, and this is equal to 20 into 12 plus 39 into 6, and this is equal to 20 times 12 plus 234, and this is equal to 20 times 246, and this is equal to 4920. Okay, so in question number 13, here we have to find the sum of first 15 numbers that are multiples of 8. Okay, so the multiples of 8 are basically 8, 16, 24, 32, dot dot dot. Okay, so here you see this list of numbers from an AP. Okay, so these are in an AP having first term is 8 and the common difference is 8. So therefore, the first term A is equal to 8 and the common difference D is equal to 8. Now we have to find the sum of first 15 terms, which are multiples of 8. Okay, so we know this formula is n, this is equal to n by 2 times 2a plus n minus 1 d. Okay, so now if we put all the values of a, d, n, okay, then we get this is equal to 15 by 2 times 8 plus 15 minus 1 times 8, and this is equal to 15 by 2 times 16 plus 14 into 8, and this is equal to 15 by 2 times 16 plus 1.2, and this is equal to 15 times 1 to 8 divided by 2, and this is equal to 15 times 64, and this is equal to 960. Okay, so sum of first 15 terms that are divisible by 8, that are multiples of 8, is equal to 960. So now let us see question number 14. So it said to us, find the sum of odd numbers between 0 and 50. Okay, so let us see first which are the odd numbers between 0 and 50. So the odd numbers between 0 and 50 are 1, 3, 5, 7, 9, dot dot dot, 49. Okay, so therefore it can be observed that these odd numbers are in an AP. Okay, and here the first term A is equal to 1, common difference D is equal to 2, and the last term is equal to 49. Okay, so now the last term L, this is equal to A plus n minus 1 times D. Okay, so here the last term L is equal to 49, and the value of A is equal to 1, and the value of D is equal to 2. Okay, so now if we put all these values, then we get 49. This is equal to 1 plus n minus 1 times 2. Okay, and it implies 48. This is equal to 2 times n minus 1, and it implies n minus 1. This is equal to 24, and it implies n is equal to 25. Okay, and now sum of first n terms, that is Sn, this is equal to n by 2 times A plus L. Okay, so S25, this is equal to 25 by 2 times 1 plus 49, that is equal to 25 times 50 by 2, that is equal to 25 into 25, that is equal to 625. Okay, so the sum of odd numbers between 0 and 50 is equal to 625. Now let us see question number 15. So in question number 15, it said to us, a contract on construction job specifies a penalty for delay of completion beyond a certain date as follows: 200 rupees for the first day, 250 rupees for the second day, 300 rupees for the third day, etc. The penalty for each succeeding day being 50 rupees more than for the preceding day. Okay, how much money the contractor has to pay as penalty if he has delayed the work by 30 days. Okay, so it can be observed that these penalties are in an AP, having first term as 200 and the common difference as 50. Okay, so here A is equal to 200 and the common difference D is equal to 50. So penalty that has to be paid if he has delayed the work by 30 days, this is equal to S30, this is equal to 30 by 2 times 2 into 200 plus 30 minus 1 times 50. Okay, and this is equal to 15 times 400 plus 1450, and this is equal to 15 times 1850, and this is equal to 27,750. Okay, so therefore the contractor has to pay rupees 27,750 as penalty. So I stop here this lecture. Thank you very much to all of you.